Hello everybody, today we're going to work on some practice problems from your very first tutorial in Unit 1, Explicit and Recursive Functions. Okay, so let's look at the first one. The first one, you're given a graph. It says the sequence graph below shows the number of bicycles detailed per hour in a bicycle shop. Determine the recursive formula that describes this situation. Okay, first of all, I'm going to plot these points into an X and Y chart that I have right here so I can better see what's going on. So I have points 1, 2, 3, 4, and 5. And the first one is 4. The second one is 8, and then 12, then 16, and then it's 20. Okay, now first we need to determine if it's we know it's recursive, but we need to determine if it's an arithmetic sequence or if it's a geometric sequence. Uh, Arithmetic, the pattern to get to the next number in the y-axis is by an addition. If it's geometric, it's going to be a multiplication. If you have more questions on the difference between arithmetic and geometric, please watch the previous video. Okay, so let's see. From 4 to 8, I have to add 4 to get to the next number. From 8 to 12, I need to add 4. From 12 to 16, I'm adding 4. So the pattern here is an addition, which means that this sequence is going to be arithmetic. So I'm going to look on the notes that I took right here. Then let's write down the formula. Okay, so the recursive function that best describes this situation is f of 1 equals 4. This is just the very first term in the sequence, which is right here. And the function that best describes, we're going to have f of n minus 1. Actually, that should have been here. That's just part of the formula. And here is the pattern, what you're adding. The pattern is plus 4, so this is going to be f minus 1 plus 4. That's it. Minus 1 plus 4. Now the next one is an f of 9 is, what they're asking you is to find the ninth number. So 5, 6, 7, 8, 9, 10. To do this, you're going to have to keep adding 4. Unfortunately, for recursive, you can't really plug in a number. You always need to know the value that came before it. So this is 24, 28, 32, 36. So the value when x is 9 is 36. So that's it for question 1. Let's see if we get to question 2. Okay, question 2. A new clothing store advertising through social media to draw customers and increase the number of transactions each month. The number of transactions f of n for n months is shown on the table. Okay, so we have our table right here. If the number of transactions per month continues to increase in this way, fill in the values for a and r to create the function that describes the situation. Okay, so what I'm going to do, I'm going to look at my equation right here. And it's on the form a, r, n minus 1, which matches this. So right off the bat, we know it's going to be a geometric sequence. Now let's see if we can get some values. A, from my notes, I can see that a is the first term. So a is going to be equal to 10. Now we need to find the common ratio, which is r. We need to find the pattern. And for geometric sequences, the pattern is always a multiplication. In other words, what do I need to multiply each term on the y to get to the next one? 10 times 2 gives me 20. 20 times 2 gives me 40. 40 times 2 gives me 80. So the pattern or our common ratio is 2. All you have to do in this question, you're going to leave f of m by itself, and you're just going to plug in the values that you have for a and r. So this is the same thing as 10 parentheses 2 and minus 1. And that's it. This is all you need to do for question 2. And finally, question 3. Okay, let's look at question 3. Daniel is collecting stamps. His grandmother gave him 24 stamps to start with. So this is the initial value. Every week, Daniel's collection increases by 8 stamps. Let y represent the total number of stamps Daniel has after x weeks. Which type of sequence does the situation represent? So I start with 24 and then I increase 8. So next I'm going to have 32 and then 40. So because it's increasing by 8, my pattern is going to be an addition by 8. Okay, now let's see if we have an arithmetic and geometric sequence. Because the pattern is adding or subtracting, we know it's going to be an arithmetic sequence. So I'm going to look at the options that I have and eliminate the ones that do not match that description. Let's see. The first one says the situation represents an arithmetic. That's a probable answer. B is the situation represents a geometric sequence. It is not a geometric. We already said it's arithmetic. And also C says that it's geometric. So it's between A and D. So we know that it's an arithmetic sequence, and let's read the rest of the sentence. Let's look at A. The situation represents an arithmetic sequence because the successive y values have a common difference of 8. So let's see, common difference is the name of the pattern, and our pattern is 8. Okay, so that seems to match. Let's read the last one. The situation represents an arithmetic sequence because the successive y values have a common difference of 24. 24 is not the pattern, that is the initial value. So we can eliminate that, and that will make A our correct answer. Thank you for watching, and if you have any questions, please contact a math teacher. Thank you.